Hello everyone, I am T. Vineela Kumari, MSc Computer Science second year from RBVRR Women's College. So today we will discuss topic Internet Key Exchange. So Internet Key Exchange is a secure key management protocol used to set up a secure communications between two devices. So for example, the two devices are communicating with each other, host A and host B. These two people are communicating with each other. The communication has been secured. So the information is not leaked to anyone. In order to secure we have the using the keys to manage the keys and exchange those keys between sender and receiver. We will be using the internet key exchange. So the key exchange is done in by two ways. First one is manual and second one is automated. In manual, the system is manually configures each system with its own keys and the keys of other communicating systems. So it has to be small, relatively static environments. The second one is automated. So we have automated on demand of creating the keys. The word automated itself says that demand creation for the cases whenever there are requirements. For those keys, only key will be created. Here it is used to large distribution systems. So the large distributed systems are involved for communications and the automated key exchange is done by the two protocols. And those two protocols are first one is Oakley key determination protocol and second one is IASMKMP. So the abbreviation of this Internet Security Association and Key Management Protocol. The first one, Oakley key determination, says that key exchange also. It is based on the Diffie-Hellman key exchange algorithm, but it has some additional securities layer over here. So we have the here genetic protocol. The genetic protocols are applied anyone. So you can apply it all systems in common. Need not to be specific for the each and every systems. The second one is Internet Security Association and Key Management Protocol. And these two protocols, which protocols are assigned for the protocols what is specific support for the each, and it does not decide the specific keys exchange algorithms rather than the consistence of messages types, and use the variety of key exchange algorithms. And here ISAKMP also provides the frameworks for internet key management, but provides a specific protocol support including formats and security attributes. Key Determination Protocol IKE. Key Determination Protocol are of the Diffie-Hellman key exchange algorithm. However, there are a number of weaknesses in Diffie-Hellman algorithm. So, the IKE key determinations are designed to retain the advantages of Diffie-Hellman while counting its weaknesses. In Diffie-Hellman algorithm has two attractive features. The first one is they are making secret keys are creating whenever they need it, and they does not need to store the secret keys long period of the time. So the increasing of the validity. So second one is the exchange require no pre-existing infrastructure other than the arguments of the global parameter. Here we have the Diffie-Hellman key exchange algorithm. So the first one, two parties can agree on the symmetric key using these techniques. The second one is this can be then used for encryption and decryption. The algorithm can be used only for the key arguments but not for the encryption or decryption. So this is all based on the mathematical principles. So the first algorithm, first step, first Alice and Bob are two or upon the agree with the two large prime numbers n and g. Why we are taking the prime numbers here? Because of the calculations will be easily found by using the prime numbers. So the first Alice will take the prime number level and Bob will take prime number as 7. So these two numbers need not to be secret, can be shared publicly. So and second step, Alice chooses another large number x, private to her, and calculator a such as a g raises to mod n. Here we taken 7, n is equals to 11 and g is equals to 7. According to this, numbers need not to be secret and shared publicly. Here Alice chooses another large prime number x and which is private to her, and this step 2 a calculates new number such that formula is g raised to x mod n. So the g will know that 7. And here we assuming x as a 3. So we are taking the small numbers to calculate become the easier. So here the 7 raised to 3 mod n. So here n will be a 343, that 7 raised to 3, and 7 raised to 3 is equals to 343. So mod level will gives to 2. Now step 3, Alice sends to this box and calculate the bob. You can see the arrow of a blue A, and which tends to be bob. A is equals to 2, and so again there is on insecure network, so any other third person can read and takes the values and equals to 2. Even though A has insecure and the key is going to be private for both, we can see that works. So let's see the fourth step, that Bob chosen 7 here, which is private to him, but 7 raised to 6 mod level, that gives to 4. And again fifth step, Bob sends to this Alice. And in sixth step, Alice now compute her secret key K1 has the following of K1 is equals to B raised to X and mod 7 mod n. So here the B value in Alice will is equals to 4. And in similarly, Bob computes its secret key K2 has following of K2 is equals to K A raised to Y mod n, and here the value of A is equals to 2. So that becomes K1 is equals to K2. Key exchange will be completed. And here we have the mathematical theory. First we took a what Alice does in sixth step. K1 is equals to B raised to X mod n. And what is B? From the step 4 we chosen. That is equals to B is equals to G raised Y mod n. Therefore it will be substitute these values on B in step 6. In step 6, K1 is equals to G raised to Y and power X. Mod n is equals to G raised to X and Y. So mod n, that will be a first one. Now take look at the what Bob does in 7th step. K2 is equals to A raised to Y and mod n. What is A? A value will be 2. Step 2, we have A is equals to G raised to X mod n. Therefore, we will substitute these values of A in step 7. So that become n is equals to G raised to xy mod n in step 2. So now basically mathematics says that K raised to x y and yx is equals to equal. Therefore, in this case we have K1 is equals to K2 is equals to K. And here we have three different authentication methods that can be used in IKE key determination. The first one is digital signatures. And in digital signature, the exchange in authenticated by signature and mutuals hash. Each party encapsulates and hash with its private keys, and it will be generated over important parameters such as using the IDs. And the second one is public key encapsulation. So the exchange is authenticated by the encrypting parameters such as IDs and sender private keys. And third one is symmetric key encryption. So in this the key will be some out of the band mechanisms can be used authentication by the exchanging the symmetric exchange of the parameters. Now IKEv2 exchanges, and it has a protocols involved for exchanging the messages in pairs. So the messages will be exchanged in the form of pairs. The first two pairs exchange refers as a internal exchanges. The first exchange of two is exchanges information in algorithms and other security parameters, and they are using the along with the Diffie-Hellman values, and the result of this exchange is set up special assay called IKE. So this assay is define the parameters to secure the channels between the bits over the subsequent messages of exchanging takes place. Here we have the example diagram of EKEv2 exchanges. So here the information of the exchanges, first one is the responder, initiator and responder. So first one is HDR, so that is equals to header, and after that SAIX is equals to offer the chosen algorithms of DH groups. And CRT is nothing but certificates, and IDX is identifiers, and CP is an configurations, and DD is a delete, and N is a notifies. And in this diagram, they contains the full forms of the all the header files elements. In header, we have playroll and formatted. So this playroll formatted provides the frameworks and independent of the specific keys exchanging from the protocols and authentication mechanisms. So first one is internet key exchange header format, and this message consists of the headers followed by the one or more payrolls. All of this carries the transport protocols, and the transport protocols are specification for the implementations of must support of the UDP for the transport protocols. And here we have the bits 0, 8, 16, 24, 31 for the initial security parameter index, and after that we have the second layer as the responder security parameter index SPI. Then third layer has the next playroll and MGVR, MGMN, VER, and exchange type and flags. After that layer, fourth layer, message ID and length. This is the IKE header, and after that we have another diagram B, genetic play rolled header, that bits contains 0, 8, 16, 31, and it is the IKE formats. And the header formats of IKE message consistent of the following fields. The first one is initializer SPI 64 bits. The value chosen the identifier of unique security associations of SA. The second one is a responder SPI that contains 64 bits. The value chosen for responder is the identifier of unique IKE. And the next third one is the next play roll 8 bits, indicates the type of the first play roll in the messages. And the fourth one is major version 4 bits, indicates the major version of IKE in use. And fifth one is exchange type, contains 8 bits, indicates the type of the exchange. And sixth one contains flags 8 bits, indicates the specific option set of this IKE exchange. It also contains the message ID 32 bits used to control the retransformation of the lots of packets, and matching request and responses to the length of 32 bits. And here IKE playroll contains three elements, and first one is processable and transformation and attribute. In first one, the structural includes the processable's number of protocols IDs and indicates that number of transformations are done to the protocols, including number of sequence and the same numbers. And the second one are used to different protocols to separate different transform types, and this has some this all used algorithms to be particular protocols. And third one is an attribute. Each transformation may include attributes that modify or complete specification of the transformation, for example the key. And here the key exchange play role can be used varieties of key exchange techniques, including Oakley and Diffie-Hellman, and RSA-based key exchange used by the PGP. And it is also identifications play role is used to determine the identity of the communicating, may be used to determining authenticity and information. And the certificate play role transforms the public key certificates. And here we have some examples of the certificates. That first one is PGP certificate, and second one is BKCS /7 wrap X.509 certificate. And we have some extra, we have more certificates. And here we have the some notify play role contain it, either error or status information associated with this SA or this SA. Following tables. First one is error message and status messages, and we have some play role invalid IAE SPI and syntax and SPI messages IDs play role types and etc. So in status messages contains the some set window sizes and cookies use transport modes and etc. And for the delete play role indicates one or more SAS that sender has to delete from its database and that no longer to valid. And so the configurations of the play role is used to exchange the configuration information from the IKE feeds. So the extensible authentication protocols EAP and Playroll allows EKE SAS to authenticate it using the EAP. Thank you.